the most expensive scientific experiments ever conducted opening music fades, in what price would you put on unlocking the universe's deepest secrets? While most laboratory equipment might cost thousands or even millions, there exists a realm of scientific inquiry so ambitious, so monumentally complex, that nations must pool their resources just to attempt them. The experiments we'll explore today operate in a financial dimension that defies ordinary comprehension, where budgets aren't measured in millions, but billions. These aren't merely expensive endeavors. They represent humanity's most costly quests for knowledge. I'm your host, and today we're venturing into the enigmatic world of scientific megaprojects that have consumed more treasure than many countries' entire economies. At the pinnacle of expensive scientific exploration stands the Large Hadron Collider, a machine so vast it spans 2 countries. Buried beneath the Franco-Swiss border near Geneva, this 27-kilometer ring of superconducting magnets represents the most complex machine ever built by human hands. The price tag? A staggering $9 for construction alone, with annual operating costs exceeding $1. The LHC required the collaborative funding of 23 nations, making it one of history's greatest international scientific endeavors. But what mystery could possibly justify such astronomical expense? Nothing less than the hunt for the fundamental building blocks of existence itself, particularly the elusive Higgs Boson, sometimes called the God particle. When CERN announced the discovery of the Higgs Boson in 2012, it represented the culmination of a 50-year theoretical journey and billions in experimental costs. This subatomic particle explains how other particles acquire mass, a cornerstone in our understanding of the universe's physical laws. Yet the questions linger in the halls of both scientific institutions and government treasuries. How do we measure the value of such knowledge? Is confirming the standard model of physics worth billions? The LHC continues operating today, pushing into ever more perplexing territory, seeking supersymmetry and dark matter, each year consuming resources that could build hospitals or feed millions. If the LHC's cost seems bewildering, consider our next scientific marvel, the International Space Station. This orbiting laboratory, hovering 400 kilometers above Earth, represents the single most expensive object ever constructed. The figures are almost unfathomable, over $150 in development, assembly, and operations since the 1980s. With contributions from 15 nations, the ISS has demanded not just extraordinary financial resources, but unprecedented international cooperation amid shifting geopolitical winds. Imagine, every 90 minutes this palatial laboratory circles our planet, each orbit costing approximately $1 when amortized across its lifetime. Each sunrise viewed from its cupola window comes with a price tag that would make even the wealthiest institutions pause. Yet the ISS has provided us with something beyond monetary calculation, a continuous human presence in space for over 2 decades. Its microgravity environment has enabled experiments impossible on Earth, from protein crystal growth to fluid physics, from radiation research to studies on the human body itself. Over 3,000 scientific investigations have been conducted aboard, yielding discoveries in medicine, materials science, and fundamental physics. But perhaps its greatest experiment is social, proving that nations often at odds on Earth can collaborate in the void of space, united by scientific curiosity. As we contemplate its eventual deorbiting later this decade, we face the baffling question: how do we calculate the return on investment for expanding humanity's frontier beyond our home planet? From the cold of space to the heat of fusion, our next costly scientific venture is ITER, the International Thermonuclear Experimental Reactor being constructed in southern France. Originally budgeted at €5 billion, this experimental fusion reactor has seen its costs spiral to over €22 billion, with completion still years away. What makes nations continue pouring resources into this seemingly bottomless project? The tantalizing promise of fusion energy, the same process that powers our sun, harnessed on Earth. If successful, ITER would demonstrate fusion's viability as an energy source, potentially solving humanity's energy needs with abundant fuel and minimal waste. The 35 nations funding this experiment are betting on a future where deuterium extracted from seawater could power civilization for millions of years. But critics wonder if we'll achieve fusion's promise before exhausting our financial resources or patience. Gazing deeper into space required our next astronomical investment, the James Webb Space Telescope. Originally estimated at $500 with a launch date in 2007, this infrared observatory ultimately cost nearly $10 and launched in 2021. Each delay and cost overrun brought questions about scientific accountability, yet the scientific community persisted. Why? Because Webb's capabilities promised to revolutionize our understanding of the cosmos, peering further back in time than ever before, potentially witnessing the universe's first galaxies forming after the Big Bang. Its 18 gold-plated beryllium mirrors, unfolded in a cosmic ballet of engineering precision, now capture light that has traveled for 13.5 billion years. What price would you place on witnessing creation itself? The most enigmatic aspect of Webb's cost is that it represents a unique experiment that cannot be replicated or verified through traditional scientific methods. If its mirrors had failed to deploy or its instruments malfunctioned, we would have lost not just money but irreplaceable opportunities to answer fundamental questions about our cosmic origins. Each image now being returned, from exoplanet atmospheres to stellar nurseries, is being meticulously analyzed to extract maximum scientific value from this extraordinary investment. The knowledge gained may reshape our understanding of planetary formation, stellar evolution, and the conditions that make life possible. Stepping back in time, we encounter perhaps history's most consequential expensive experiment, the Manhattan Project. Between 1942 and 1945, the United States invested approximately $2, equivalent to about $33 today, to develop the first nuclear weapons. This crash scientific program employed over 130,000 people across secret facilities, culminating in the Trinity test and subsequent warfare deployment. Beyond its military implications, the Manhattan Project represented a turning point in how governments fund and organize science, establishing the model of massive, coordinated research efforts that continues today. The nuclear physics knowledge gained would later enable civilian nuclear power, nuclear medicine, and countless technological spin-offs, yet at a moral cost that continues to haunt scientific conscience. As we contemplate these monuments to scientific ambition, we face perplexing questions about value and priority. With limited resources, how do societies decide which mysteries merit such extraordinary investment? What discoveries remain beyond our reach simply because we cannot, or will not, allocate sufficient resources? The experiments we've explored today represent more than financial expenditures. They embody humanity's deepest aspirations to understand our universe and ourselves. Their costs, while staggering, must be weighed against the incalculable value of knowledge gained and boundaries pushed. Perhaps the most thought-provoking aspect isn't how much these experiments cost, but rather how much we're willing to spend on expanding the frontiers of human understanding. In the ledger book of civilization, what price do we assign to answering our most fundamental questions? The next decade promises even more ambitious scientific ventures, from proposed particle accelerators that would dwarf the LHC, to Mars sample return missions, to quantum computing facilities that could revolutionize our computational capabilities. Each will demand extraordinary resources, and each will face the same scrutiny. Is this knowledge worth the price? History suggests these investments, while sometimes appearing extravagant in their moment, often yield returns that transcend their original purpose, spawning technologies, inspiring generations, and reshaping our understanding of reality itself. As we conclude our exploration of science's most expensive endeavors, I leave you with this enchanting thought. Every time you use GPS, benefit from medical imaging, or marvel at photos from distant worlds, you're experiencing the dividend from some previous generation's investment in expensive, scientific curiosity. Thank you for joining me on this journey through science's most costly frontiers. If you found this exploration fascinating, please subscribe for more ventures into the mysterious realms of unusual science. Until next time, keep questioning, keep wondering, and remember, knowledge may be expensive, but ignorance ultimately costs far more. Closing music fades in.